Hello, thank you for joining us for today's Ask the Pet Food Pro Chat. This series is brought to you by Pet Food Forum and the editors of Pet Food Industry, the magazine and digital content provider with decades of providing the market with pet food expertise. You can find our content at petfoodindustry.com. Ask the Pet Food Pro offers a great opportunity to connect with industry peers and experts and ask the questions that are most on your mind while learning information to help you and your company provide high quality pet food and pet treats. Today's chat is about how to maintain a food safety and a food safety culture in older pet food processing plants, and it's supported by Ecolab. Thanks very much to them. Our expert today is Andy Dean, Area Technical Support Coordinator for Ecolab. Welcome, Andy, and thank you for joining us today.
Good morning, everybody.
Before we start the Q&A and discussion with Andy, I do have a few housekeeping notes. First, you've all been muted to ensure everyone can hear and focus on the discussion. So please submit your questions or comments in the chat box. Some of you submitted questions beforehand, which we really appreciate, and we'll try to get to as many of those as we can, along with the ones submitted live. And then finally, this chat is being recorded. You can access the recording starting in about a week at petfoodforumevents.com, and then click on the Ask the Pro tab at the top. So with that, let's get into the discussion. Andy, do you want to start with an overview of how where we're going to go today with this discussion, please?
Well, we're going to go in a lot of different directions, and I like to try to keep it dynamic. We'll probably have a couple of questions that maybe or maybe not related to the topic, but we'll field as many as we can. So Please use the chat as much as possible. The real intention is to really focus on the tips to maintain food safety, particularly with aging facilities. And I'm going to kind of start this off with just a general question, just to kind of make people start to think a little bit. So who all drove into work this morning? So when you start thinking about driving into work, there's a lot of things that need to happen to make things go smoothly. Did you consider how far or how long the drive would be, or what the road conditions would be like? It's not wintertime here yet in Wisconsin, but weather will change, or what the traffic might be like. That's kind of relating to geography and location. Considering the condition of your vehicle, you have gas in the tank. Is it a 10-year-old vehicle? Is it a new vehicle? Are you familiar with all the controls and operating features? Man, I should really get that check engine lights fixed soon. So that's looking at design and maintenance for your vehicle. Is it suited for that application, that geography? Most of the time, you don't want to run a convertible in the middle of winter. And then, did you need a map? Do you know the drive? Is this a simple series of stops and starts and turns? Hopefully no detours. And that's really kind of the process flow. When you're looking at any new facility or even an existing facility, there's a lot of things to consider for food safety and just general plant operations. And probably the number one that most people think about is location. How am I going to get things into and out of the plant? So logistics. What does the labor pool look like in this geography? So that location piece plays a pretty significant role. And then looking at the design, the sanitary design, looking at both infrastructure and the equipment. So we really want to protect against anything for contamination, good materials of construction, ease of maintenance. So we're able to take things apart. We don't have harborages and nooks and crannies and things that can go bump in the night. Looking at the air handling systems, how air moves about the plant, how we're going to handle waste. So those are all part of those design criteria. And then also looking at the process flow. Does it make sense for this logical series of events? Are they value-added sequences? There's two key terms that usually come up with process flow, and one of them is effectiveness. So producing a desired result, doing the right things, and then efficiency, using that useful output relative to an input. So are we doing the right thing? So doing things right and doing the right thing. And that can involve traffic patterns and zoning, and then striving for that linear process. So we're not making lots of different side jumps because the facility is harder to clean. Older facilities don't necessarily follow that nice linear process. We may have additions or changes in our process flow that we have to deviate from that linear, and that creates more problems with process flow.
That's a good analogy between getting to work and going through a pet and the production process through a pet food plant. So what are the biggest food safety challenges you're seeing right now in the industry?
Wow, that's a fun question because the pet food is everybody's seen a tremendous growth phase, consistent growth, 5% up to double-digit growth-ish.
Right.
It depends on what market and what area you are, and this can really compound some of the issues. If I'm looking at the top three, the common threads would be supply chain issues. Again, since COVID, we've really had it exacerbated a lot of the supply chain issues. Plant efficiencies and production uptime, that's really an important focus for how that plant runs, and that supply chain can impact part of that. Rising demand for product. So when you're in a tremendous growth phase, are we able to make the volume that we need to distribute to our plants? So that's where that uptime really becomes that important focus. And then how efficient is our operation? Downtime, sanitation time, anything where we're not producing product, it actually costs part of our availability. Aging infrastructure can really impact that by having additional downtime to make necessary repairs or capital investments to make things doing the right things. Anytime we're dealing with sanitation and we're not producing product, how efficient and effective is our sanitation program? Rising costs, everything's going up, including labor. Probably the next bullet point would be regulatory. So there's increasing focus and awareness of food safety, not just from our customers, but also from regulatory agencies. Aging infrastructure, even new equipment gets dents and dings and scratches. How we repair and maintain that equipment becomes really, really important. It's actually crucial or critical. And then looking at equipment from maybe even a decade ago, things have changed a bit. From an OEM perspective, or original equipment manufacturer perspective, they're trying to do things right and make it support the actual functions and food safety culture for the individual plants that we're working with. So that's always being considered for the sanitary design improvements. The last big bullet point is probably, I'm going to call it labor. There's a lot of changeover. Everyone, raise your hand if you're not experiencing this, because everybody's been in this crisis of, we don't have enough people. We can't get enough people. And then we're training people that are coming in that may be being pulled from non-food production, industrial or automotive, or even retail are coming to work in a food plant. They don't have the culture. If you go back 20 years ago, there was a real strong food safety culture back then because people knew what they were supposed to do. They had worked in a food plant for many, many years, and we've lost a lot of that. Now with the quick changeover, training becomes super, super important. Less retention, more training, more time. Quality of training is paramount to integrating that successful workforce. And then communication also plays a role in that labor pool, keeping real open lines of communication. So we're not just direct down, we're actually hopefully being able to communicate 360 degrees to relay the important and critical key operating parameters in our mission statements and keeping everybody on the same page. So that honest and open communication really needs to be there.
Okay, so you touched on a lot of things there, and I'm assuming we're going to probably dive into many of those during the discussion. But to start, I mean, I know that every plant is unique, but when you first enter a plant, what is the first place or the first thing you look at in terms of, you know, is everything operated in a safe way?
Let me think about that for just a second.
Okay.
So normally when I get called into the plant, there's usually some sort of an issue. I'm one of the technical support coordinators. So I go in when there's an issue that needs to be solved. The first question is always, what's important to this customer? So where's the point of pain? And this really does vary on what we're focusing on. It could be a micro concern. It could be a quality concern. It could be an operational where we need to to save some costs or cut down some time. So most importantly, it's understanding what's important to that customer. In some cases, if I'm working on a micro issue, walk into the plant and I can see a piece of equipment I know is the issue. That's not always the case, and you'll have to dig deeper. It's not real common to just like, aha, that's the smoking gun.
Right.
So I do have a secret recipe, and there's 3 keywords to this. It's listen, ask, and look. So listen to what that concern is. Where's that point of pain? Have an open and honest communication to really get the significance that this is our true issue. And then ask. When you talk about ask, you're going to go into those 5 W questions: where, what, why, when, who. What is the specific issue? When did it occur? You might have a seasonal issue. We may have had some changes. So if we have a change management program, something may have changed that we can go back and say, aha, we have this, we made this change and added in product XYZ to our formula, and now we're having issues. When seasonal issues can play a big role with micro, with roof leaks and changes in relative humidity, even changes in weather. Ask the question.
I'm assuming pests.
Oh, absolutely. Windows and doors being left open in the summer, that's usually that's a big one. So good add-on, Debbie. Thank you. Ask what's been tried. So follow the corrective action, preventative action. So they may have already tried some things. Hopefully it wasn't a shotgun approach. And then the problem went away, but we tried 12 different things. We really didn't solve the problem. It's probably going to come back. And then what does that data say? Everybody has data in the plant, whether it's paper records, electronic records. If we can do some visual interpretation of what that data says, pretty important. And then getting into the look. So we're going to review the documentation. What does that data tell me? And then physically look at the conditions in the facility. What do you see? What do you smell? What does it feel like? What is the overall aura of the plant? Then start looking, vectoring in, looking up, looking down, looking under, even looking inside. If you do look inside, make sure you're following those safety protocols. So it's listen, ask, and look. And that I do that same recipe every time I'm in a plant.
And it sounds like it's a recipe that an internal operator, so if someone on the call or listening in right now is the, safety manager, quality manager, or, that's something, a recipe they can follow too internally, right? Okay, so kind of moving in a little bit different direction. There are a lot of digital food safety tools popping up these days, a lot of AI, Internet of Things, that kind of thing. Are those an option for older facilities?
Data everywhere. Everyone's got data. If we've progressed anywhere from clay tablets and casting things in stone, you probably have data in your plant. It's just what you do with that data is what's crucial. What are the metrics? Are we treasuring what we measure? And that's kind of a really active program. If it's not important, why are we measuring it? If we are measuring it, what are we doing with that data? So how is that data cataloged, and what do we do with it is probably the most important part of that. Communicating objectives. So if you're using that data, what trend is it showing? Are we moving forward? Are we moving backwards? Is there no change? So those analytics and trends really help. And you probably already have these in most of your facilities with environmental monitoring programs, PM programs, pre-op inspection programs, risk assessment. You follow a decision tree. So you probably already have that information. Use that data because it's got some really good nuggets of wisdom in it. Ecolab does have a feature that we're rolling out called our FSQ Supervisor that's actually trying to help manage some of that data. So there's a lot of things going on. So it doesn't matter how old your facility is, data is available. We're doing things differently. We're making things smarter and faster and more effective.
So the short answer is it doesn't really matter the age of the facility. If you want
Yeah,
to use, you want to, and probably it's a good idea to use some of these digital and data tools to help you uh, set your food safety program and maintain it and train.
yeah, absolutely, because you're probably already doing it. You're just calling it a different thing.
Right, right. Um, and then you mentioned labor, and that is a huge issue in every industry now, but including in pet food. So in plants, which is most plants, where there's turnover or understaffing, what are some tips for maintaining a good food safety culture in that
Well,
kind of environment?
that's pretty important for food safety. Um, Define what is food culture. So, what is food culture for your facility? So, Debbie, when you think of food culture, what do you food safety culture? What do you think of?
I think of everyone being on the same page, and I'm not a food safety expert, so this is very much a high level, a layman's term, layman's explanation, but I think of everyone being on the same page in terms of what's expected, what the procedures are, um, what every single person is responsible for in that whole process.
So, if you look at things from an overview, having and promoting that food safety culture is really crucial for long-term success. Not a perfect recipe. There's not one size fits all for every facility. So it's not about doing something new or something different, or logging all this data. It's finding out what works for your organization, because everyone is a little bit different. So there's some really key drivers that you should focus on. Number one is define what is food safety culture. What is your main driver? Is it a mission statement, a commitment, or a promise? And then live up to that expectation. So that's really important, that you're walking the talk and talking the walk. So everybody's doing the same thing. It doesn't matter if it's an operator on the floor, a janitor, a vice president of operations, a quality manager. We should all be driving toward that same thing, those same key mission statements or purposes. Another one that's really important is communicate. So communicate 360. And I can't say communication enough, because that's really important. Even the relationships between departments. I've seen some really bad adversarial. Sanitation is causing all the downtime, and maintenance isn't fixing things, and production's running too long, or they're not picking up their stuff. We're all in the same program. We're all supporting the same endeavors. We want to make food that's safe, on time, and available at the lowest cost. We have the same goal. Let's work together. That's really, really important. Conversely, I've also seen plants that work really well together and their programs start to mesh. So we're all working toward that same goal. And when you get a good mesh between departments, we're actually working together. So it's not just 1 + 1 = 2. It really builds exponentially, and things move. People, you're breaking down that fear barrier of, ooh, I broke something, or we're doing something a little bit different. If we think about things for that common goal, we'll work together and build.
Okay, those are good tips. Let's get a little bit more technical now, because we had some technical questions come in, and including one today. So a lot about contamination and cross contamination, including with airflow. We had a general one come in beforehand about how controlling cross contamination through airflow. We had one come in a little while ago today about how probable is it to get bacteria contamination through airflow from condensers in processing plants. That's very specific, but it seems like there's a lot of there's some concern out there about cross contamination and airflow.
Oh, it's definitely a possibility. So how we're maintaining the air balance in the plant is even as important as what does that filter system look like. So when you're looking at cross contamination, the very first thing when I go into a plant is, what does your zoning look like? How are we maintaining hygiene zones in the facility? Do we have areas of high care or low care? And then connecting hallways and interstitial spaces, air handling systems, drain systems. How are we keeping all those zones physically separated so we're not getting and imposing additional risks? number one would be what does that map show you of the process? Air balance, high pressure, and higher hygiene areas to keep things evacuated. When you're looking at your air system, what's your master sanitation program say? How often are we cleaning it? Is it cleaned effectively? What is the conditions? Some of the repairs and maintenance to that system is what kind of filters are there? What is the MERV rating, or minimum efficiency reporting value? I'm pretty sure that's what MERV stands for. So how that air comes into the plant, are we filtering out not just the big bugs and heavy debris, but is it suitable for the hygiene condition in that room? Most of the common filters that you'll see in just regular processing plants is 9 to 12. You get into some of the high care areas, you might have a MERV value of 15 to 17, kind of in that HEPA zone. Where's the air intake? If it's up on a roof, what does the roof look like? Are there gaps on the sides of the filter that it's bypassing a filter? Are we pulling in odors and micro right from an area of a spill on a roof? So that's another really good one to look for. Look at condensation. Changing seasonal values. You may have different tempered air, different relative humidity that can cause condensation. Condensation in any plant is bad. In a dry plant, it's critical. So right. Where's that coming from? And then really looking at what that sanitary condition of that air handling system is pretty important. Other areas of cross-contamination, I would look at adjacent line cleaning. So if you have two parallel lines, one goes down for sanitation, the other is not, that's a big risk. How things are handled, how people are trained, what tools are available. I go right back to what is the risk assessment? So I'll go in eyes wide open, look at potential causes, potential risks, and then how can you mitigate those risks? That's a really good start is doing a good risk assessment.
Okay, and it sounds like there's a lot of different places and things to check.
A lot of avenues.
It's not just a condenser, for example, or a specific piece of equipment.
Correct.
Okay. This is a question that came in, and it's going to show my ignorance. How to set ATP limits in older equipment?
I would work with your vendor. My favorite ATP value is 0. Is it always going to be the case? Probably not, but find out what is the definition of clean. Clean may be 100. It might be less than 1,000. And again, it ties right back to what's my risk assessment, what's my hygiene, what's my risk to the product. It can actually change in different types of equipment, different processes, different areas of the plant, or even different types of equipment surfaces, stainless steel versus rubber. That's a great question for sanitary design. So if you have a high ATP number, what does that tell you? Does it mean that the equipment is bad? Possibly. It could also mean that we're not using the right chemistry or applying the right temperature, or we deviated from our standard operating procedure for sanitation. So there's a lot of things that can go on. It's a good number. It's a good thing to use for an investigative, but it doesn't necessarily tell you this is our issue.
What does ATP stand for those of us who are
adenosine triphosphate? So it's like fireflies. You'll take it's a chemical reaction using luciferin luciferase reaction. When it picks up mitochondrial ATP, it'll light up, it'll fluoresce, and it'll give you a relative light unit based on whatever type of unit you're using, and that unit will tell you, yeah, we have something there that had mitochondria at some time.
Okay. I think that's very useful information for us all to know.
If you want more, you can follow up with me, and I can talk for hours on ATP too.
Okay. And yeah, for everyone on here, Andy and his team at Ecolab will get all of your questions and contact information. So, please put a note in the chat box if you want follow up, and they'll be sure to do that. So we're talking about equipment. So let's keep on that topic for a minute. A question is, in regard to product contact equipment, so equipment that's actually contacting the product, are there any minimum standards for grades of stainless steel and surface roughness or grit? And I know we had another question about standards, so that may be getting a little outside of the scope, but it seems there's an interest there.
Well, if I had my druthers, if I had my choice, everything would be high polished stainless steel 316L. It's going to be pretty costly. It's going to hold up fairly well. And as soon as you hit it with a scratch pad, it's going to have a rough surface. It doesn't matter what surface you put on initially. It's how you maintain it, how you weld it. Do you have good sanitary welds? The biggest issue that you run into is elastomers. Are we using the right elastomer or right plastic or right rubber? Sorry about that, for that application. Buna N rubber doesn't hold up very well, but it's very, very pliable. Looking at conveyor belts, one of my nemesis types of belts is a fiber reinforced belt, because those fibers will wick moisture in and make it very difficult to clean. So it all ties back to sanitary design. Is there a set standard? Probably. I don't know the standard exactly, but it's got to be a cleanable. So I go right back to the sanitary design standards. You can look at American Media Institute. They have their 10 standards. There's probably 12 other agencies out there that have sanitary design criteria, and just follow those.
Okay, and actually that's a good segue, because we did have a question coming beforehand about, what are some standards to follow. So you mentioned American
Media Institute, AMI standards. If you type
Media.
AMI sanitary design standards, it'll populate on Google.
Okay. So that sounds like a good place to start. And those are all follow along too with like chemical and microbial standards too, or are those separate?
Chemical is a whole different animal.
Okay.
Because when Ecolab sells chemicals, we sell service, we sell support. When you're looking at chemical selection, there's really 5 big factors for chemical selection. And I know I'm deviating, so tell me if I'm getting long-winded, Debbie.
No, because we have some questions about specific types of cleaning devices or materials. So I think this is actually a great procession in the discussion.
So when you get down to chemical selection for detergents, it's looking at the soil. What type of soil are we taking off? What is the substrate? So it goes right back to that same question. What is the surface that we're trying to clean? What kind of water do we have? Because water makes up 90 to 95% of that detergent volume. Do we have good quality water? Do we have contaminants in the water? Do we have hardness in the water? Anybody that drinks coffee and has a coffee pot at home has probably seen hard water staining. Method of application. So if we're looking at a CIP system versus a manual cleaner, 2 totally different chemistries. One's going to have a lot of surfactant in that'll foam. The other will have a different package that won't foam, for like a CIP system. And the last one is really environment. So what criteria do we have? Do we have to have a minimum phosphate protocol? Do we have to eliminate nitric acid, or do we have a quat concern? Or so those are the big 5 factors when you're dealing with chemistry.
Okay, and then in terms of sanitizing and using a sanitizer, is there a specific FDA approved or mandated amount? It sounds like this is all very dependent on your situation.
I love this question, because this is a topic that we get into quite often. With any of the sanitizers, they have to be an EPA registered sanitizer. And you'll actually find the EPA registration number right on the product label. So looking at cleaning chemistry versus antimicrobial or sanitizer or disinfectant applications, the label is really the law for sanitizers. So you have to make sure you look at, is this registered for that application? The most important thing with sanitizers is, well, number one, follow the label instructions, but it's contact time and concentration. Is this product being used as a no rinse sanitizer, or is it being listed as you have to follow with a potable water rinse? And that'll all be highlighted on the product label. You also might find specific applications. So if you're going to use a sanitizer for a belt treatment or a belt spray treatment, or you're going to use it for a non-porous casing, you may have an approval listed right on the label for that. So I said 5 factors for cleaning chemistry. There's probably 7 or 8 for selecting the right sanitizer.
Okay.
So again, substrate, what is the equipment, what is the organism of concern, what conditions of water, what temperature, the cleanliness of the surface. Oh, I'm gonna get on my soapbox here for just a minute. You can't clean
intended.
You can't sanitize a dirty surface. You just get clean dirt. So the cleanliness of the surface really does pay dividends. If you have a lot of organic carryover, like chlorine, for instance, it gets totally deactivated by organic content. So if it's not clean, it's not sanitizing. Looking at the method of application, whether again it's foam, CIP, a gel, a dry spray, and then do we have any residual activity that we need?
So it's not an FDA.
It's not FDA, it's EPA.
It's EPA. And is that true with cleaners too?
No.
No.
Other way around. And it really
just to keep people confused.
If you really want to shake the tree a little bit, you get into organic, and that changes the regulations and guidelines a whole lot more. Follow the label instructions for anything that's got a sanitizer. For any of the cleaners and detergents, follow the catalog sheet, the technical sheet, what the SSOP is. That's going to be part of your validation and verification for your sanitation program.
Okay. And then we had a question about cleaning devices that you can install in a wet pet food plant. So in areas such as meat preparation, emulsions, steam cooking, fillers, things like that.
Oh, CIP is a good fallback. So CIP clean in place so you don't have to disassemble. It's not the be all end all or best fit solution for everything. But it can really help with cleaning performance because it's running that automated sequence and series of events, but the equipment has to be designed for it.
Right.
There are automated brushes and things that can be put on. Again, I'm going to fall right back to the same thing. What's my risk assessment? Do we pose a risk by including an additional brush with a hard bridge area? How is that brush maintained? How is it cleaned? If a brush is put on during production, is there a risk of having one of the bristles come out and be a physical hazard instead of a microbiological hazard?
Right.
So look at your equipment. If you can go right back to the AMI standards or the sanitary design standards, and you can design things that are fully disassemblable, easy to clean, a lot of times you don't have to incorporate additional hardware, but there are a lot of tools available.
Okay. We actually had several questions come in related to clean in place. And another one was related to, can you use or have you used inline spectroscopy to measure CIP stages? So either UV or NIR.
Well, let's start with the big CIP question first. There's a long history of CIP in the food industry. A well-designed CIP system's going to be able to clean the liners, clean the circuit, or clean the vessel with minimum disassembly of those components. That's really the focus and crux of CIP, to make sure that we're getting clean product, safe foods, quality foods. Effective, repeatable sanitation is really the driver for that CIP. It's running automated controls and set points and parameters, logical sequence of events for each piece of equipment. Can also help with employee safety. You're changing your chemical programs. You can run at a higher temperature, higher concentration. You can document either with a chart or a trend or a historian, again, tying back into that data package that actually can assist with setting objectives to optimize that CIP, to cut down on water, cut down on chemistry, cut down on time. So that's the big things to drive CIP, but there's a lot of things to consider.
Right.
Consider the process. It takes automation. So are the valves automated? Do we have to replace all the valves? Do we have utilities available? Steam, electric, water, drains. It can be very costly. A CIP system can be very, very costly on the front end for a capital expense, but it can pay long-term ROI. What's the available footprint? So how big is this thing? Will it fit into my plant? Will it fit into my design criteria? And then going through that logical sequence of events. Ecolab calls it a 4x4. You can call it 7 steps, 11 steps, 12 steps, whatever you want to call it. It really ties down to 4 things. We're going to rinse, wash, rinse, sanitize. During that wash step, we're paying real close attention and we're logging the data for the time, temperature, concentration, and mechanical action. And I said there's a lot of different sizes and configurations for CIP systems. You can have a single use, you can have, so it's a single tank, it's using fresh water for every step of that 4x4. A reuse system where we're either reusing the caustic or we're reusing the acid wash and just topping up the dosing. And there's recovery systems that can be used to recover post-rinse water and use it again for the initial rinse on subsequent CIPs. So selecting the right one really depends on what you want, what you need, what's the desired outcome. The second part of that question was, how is it monitored? And you said spectroscopy, UV, near infrared. Yeah, those are things that could be considered, but a lot of the CIP systems already have hardware that's in existence. When we start getting into spectroscopy, we're actually transmitting a light beam through our solution. If that solution is cloudy or it's opaque, it doesn't transmit very well, so it's very hard to see. Near infrared would probably do a little bit better. Not really available. I haven't seen any of those types of systems on a CIP. So it's an interesting concept. I'm really excited about digital technology and new devices, new hardware. But we already have some really functional, and we've had it for many, many years. We have RTDs for temperature. We have analog gauges. Conductivity meters do a really good job with measuring conductivity. You can also use the conductivity. So anytime we add solute to our solvent, so anytime we add soil into our water, it's going to change the amount of electricity that can carry. So conductivity does a really good job with chemical concentration, but you can also use it on rinse water recovery to kind of do a proof of, yes, we've removed the amount of soil to advance to the next step and even take CIP optimization to the next level.
Okay, that's a lot to consider, but good, great information.
I was probably speaking really, really fast because I get really passionate.
Okay, no, I think it was great. Going back a little bit more to specific materials and things to use, someone was asking if you have suggestions on antimicrobial fogging of production in areas and equipment.
Absolutely.
Okay.
My question is, why are we fogging?
Okay.
Is it a Band-Aid? I don't like Band-Aids because it doesn't fix a problem. Is it approved? So if we're looking at an antimicrobial, looking at a sanitizer, is it approved for a fogging condition? So can we actually fog that equipment? The problems that we normally run into with fogging is we fog a room and it's got to stay in suspension for a set duration, followed with a full evacuation for a set period of time down to a baseline level. It can take a long time if it's done right. The issues is that equipment poses is we're not fogging just an empty room. We're fogging equipment. We're fogging an area with overhead utilities or light fixtures that cause shadows and zones that can't be fogged. My favorite is to not fog and do a coarse spray, no rinse concentration sanitizer on every surface. And that way it kind of guarantees what's going on. Air handling units probably could be considered for fogging, or chlorine dioxide. There's a lot of treatments available. But fogging doesn't solve a lot of the problems. It doesn't clean, but it can help with areas where we're getting some airborne cross-contamination. So I can't discount it, but make sure we're doing the right thing at the right, making the right choice.
Gotcha. Okay. Someone just commented that fogging can be useful for inaccessible surfaces, like, for example, an airlift pipe.
Ties right back to what I was discussing with the sanitizer. It's got to be clean first, otherwise we have clean dirt.
Okay, makes sense. Makes sense. So you mentioned in the beginning regulations, and that's obviously a huge topic and could be a discussion all on its own. A specific question was, so say a plant has taken an environmental hit, what steps do regulations want to see that company take?
Corrective action, preventative action is probably the bottom line. I am not a regulatory expert. I'll be the first to admit it. I don't know the CFR. I don't know AAFCO. I can't recite and pull out passages from memory. So I'm not an expert, but there are a lot of regulatory experts.
Right.
If you're looking at the FSMA Code of Federal Regulations, it's very similar between pet and human food. We're following the same criteria. What's the goal? Safe quality food. So that's where I would refer to any regulatory questions. Ecolab does have a regulatory team that really does just focus on regulatory. So if there's a specific application or specific concern, I would reach out to our team and we can actually take those on a case-by-case basis.
Okay.
One of the things that is probably going to be asked is allergens. Has it been asked already, Debbie?
No, actually, I think we were that had come in terms of airflow.
Okay.
And I kind of missed asking that. So yeah, let's talk about allergens now.
So allergens, as of right now, the last time I read through, and again, I am not a regulatory expert, food allergens are exempt in pet food facilities, but it doesn't mean it's not going to come in. Things do change. Always refer back to who's the regulatory agency. And that would be the FDA, so FSMA. And I believe if you look into the code, you'll find that pet food is probably still exempt. I can't speak that that's fact.
So what you're saying is that currently regulations do not say that pet food has to control for certain allergens.
Yeah, but the foodborne allergies, so the big 8 plus 1 sesame, the recent addition.
Okay. So we probably didn't help the person who posed that question, but there are resources out there. So FDA.gov. Someone did just confirm that allergens are still exempt in pet food. Thank you.
Correct.
So FDA.gov, and yes, that can be a little bit hard to wade through it, but AAFCO.org, AAFCO.org may also be another avenue. And there are tons of companies and consultants in the industry who, focus on regulations. So.
AAFCO, Association of American Feed Control Offices, officials. Yes. That's it. I can remember, but it's not perfect.
And they really deal more on the ingredient side, but I do believe they have some food safety type information on their website.
That's a guidance organization.
Right. Thank you, Melissa, for putting the the URL in the chat box there. Let's see. One thing we didn't touch on, you kind of mentioned briefly physical contamination. So, for example, metal getting into an extrusion process. Can you address that at least briefly, please?
Yeah, extruders can be kind of a problem. They're hard to clean. They have to be disassembled. Sometimes you can see FEM, and it really depends upon how they're designed, how they're set up. What is the OEM guidelines? So there's a couple of real obvious answers: is utilize a risk assessment. So evaluate the process, focus on material, foreign material, looking at the equipment interior. If we have spalling, scratches, scrapes, there's a higher probability that we're going to get metal downstream. Metal detectors. Can we put metal detectors in process? I know it's more hardware and we're inspecting rather than preventing, so that's a good thing to add in. Sanitary design, making sure that we are picking equipment upstream before the extruders that is appropriate, that we're not getting spalled metal or corrosion or things coming off. When things are physically disassembled and cleaned, make sure we're using the right tools. Scratches and scrapes, again, that causes more spalling and metal fractures. So use appropriate tools. I love plastic tools, but it takes a little bit more physical, mechanical action. Work with maintenance, and then again, this is where maintenance and sanitation should really be very good friends, at least on a talking basis, because maintenance will actually can help support maintenance by sanitation can help support maintenance by letting people know that we're having issues taking things apart, and maintenance can help by finding problems or a better way to do things and a better way to repair things to make it easier for sanitation.
And I know that the equipment manufacturers often can help in
correct
in specific instances too.
So. With extruders in particular, there's two other things that have to be addressed: is thermal shock, making sure that we're not shocking our extruders with that real quick temperature change, because that can cause critical damage. And how dies are handled. I've seen a lot of fractured dies. So when we take the die off the end of the extruder and change it out to a different one, and that die gets dropped on the floor.
Yikes.
It doesn't last very long. It gets chips and cracks, and you might not even see the cracks until it's too late, and then you've got metal in your process. And it's a product that looks kind of a different format because the die is broke.
Yeah. There's just so many things that can go wrong, aren't there?
Oh, there is. There's a lot of things can go wrong, but a lot of things can be done right up front.
Right. So it really goes to the planning and establishing the food safety program and culture.
Correct.
Is there one thing or one food safety tip that you're seeing on a regular basis that that companies are just skipping or plants are just skipping? Is there one or two that you can identify?
Probably one of the biggest ones is water. How water is managed in your plant. So if you walk into a plant that's having micro issues and they've got water all over the floor, and you can track footprints and material handling, and you see dirty floors going through water or drains, that's a problem. Minimize water. Keep water and those zone 3 surfaces clean as well. Probably another really good point is operational sanitation, aka housekeeping, so we're not getting heavy buildup or piles and piles of product built up on the floor. So housekeeping pays dividends, and then making sure we control water. Those are probably the two biggest takeaways you could get. Okay, big bang, yeah. big return with very little investment.
So the basics, but they're very important.
Yeah. And I preach this all the time. Go back to basics, because if you don't have the basics, you can't build a cathedral on a poor foundation. It just doesn't work.
Right. What about dry cleaning? And okay. I don't think she means clothes. I think we're talking of. Sorry, that's where my brain went. What about dry cleaning in a plant?
Love dry cleaning. It's becoming much more focused. There's a lot more tools, a lot more hardware. So you go right back to those same logical sequences of steps. The most important part of anything, whether it's wet cleaning, CIP, or dry cleaning, is how we prepare. Do we have the equipment that's set up? Are we doing all of our pre-staging? Do we have the right tools for the job? With dry cleaning, we're taking water out of the equation. So our mechanical action is done by tools, and it's usually scrapers, brushes, and vacuums. So when you focus on a vacuum, make sure it's a HEPA filtered vacuum. They're expensive, but it's got to be suited for that application. If we go to Sears and Roebuck and pick up just a standard shop vacuum, it doesn't have the filtration. So anything that we're picking up gets ejected right out the exhaust. And I call those, instead of vacuums, I call those inoculators, because we're just inoculating the whole environment.
Okay. So that actually gets back to your previous answer about water. So dry cleaning helps address that.
Yeah, so dry cleaning, you're actually taking water out of the equation. So we're changing the methodology. We're even changing some of the chemistry. And dry doesn't necessarily mean total absence of water. It just means tighter control on how we're handling things. I was actually in a plant where they had several pieces of equipment in series, and they were dry cleaning, and then every once in a while they would do a wet clean. And I asked, the question is, why can't we disassemble these pieces of equipment? They were actually on wheels, roll them out, do wet cleaning into an adjacent clean room, bring them out after they're cleaned and dried, put them back into place. And it was like light bulbs went off. So, oh my God, that's a great idea. So you can wet clean some equipment by taking it out of place. It's how you clean the equipment, how you maintain the full environment. Because dry cleaning is focusing more on environment, keeping that whole environment dry. You can wet clean and bring things back in that are cleaned and dried, no problem. And then looking at the chemistry, we're driving out water, so you're using a lot of alcohol-based sanitizers. You can have lactic acid-based sanitizers that actually two-step, a clean and a sanitize with one chemistry in two separate steps. So there's a lot of focus on cleaning chemistry for dry applications as well. Again, you have to know the same criteria, the soil, what is the soil conditions, what is the equipment, do we have compatibility issues? So it's asking the same logical sequence of events for chemical selection for that application too.
Okay. Back up to the original concept of this discussion about aging plants. How, I mean, what on average would you say, or do you know what the average age of a pet food plant is in this country, for example, where we're talking about? And I mean, is there a certain point where you start to see more issues in terms of the age of the plant?
I would say it varies, or in Andy terms, it depends. You'll see a lot of older plants are dry manufacturers, and they weren't originally purpose built. So it might have been a dairy, it might have been a warehouse at one time, and it brought in a new process or a line. So it goes right back to how the plant is laid out, right back to those initial success criteria. What's the process flow look like? Do we have good separation? Do we have good zoning? Do we have good control? I can't give you a specific age. I don't know. But what I can tell you, a brand new plant, if it's not maintained and we don't have a good thought of keeping things running well, keeping things clean, it doesn't matter how old it is. It's going to be a risk very shortly if you're not looking at maintaining it, it's going to fall apart.
That makes sense. Back to the cleaning, we just had a question come in about using steam. What are your thoughts on that?
Steam can actually be used as part of a dry cleaning, can also be used as wet cleaning. Know what type of steam you're using. Saturated steam, not really a good one for dry cleaning. You want to go to a high pressure steam or a dry steam. Right. Look at your equipment. I've worked with a couple of equipment vendors. They have some good equipment, but it's a tool. It's not necessarily the correct tool all the time, but it's something that you can use in some applications extremely successfully.
Okay. We have a few minutes left. Is there anything that we haven't touched on that you really wanted to get across to people in terms of maintaining food safety?
I'll go right back to my 3 baseline words: listen, ask, look.
Okay.
So listen. So if you are the quality manager, you're the sanitation manager in a plant, listen to your people, find out what they're having for concerns, ask the right questions. So why is this a concern? What can we do? What have we tried? and then to physically go out and look and determine this would make sense if we did X, Y, and Z. And you can use that recipe over and over and over again. It's continuous improvement. Probably the hardest thing that anybody's got to do is dealing with culture.
Right.
So if you don't have a strong food safety culture, it's a real big challenge. It's hard to get the traction needed. If you're not able to walk the talk and talk the walk, boy, things fall off because it's not deemed as important.
Right. Yeah. Yeah. I mean, it's what they always say about the success of any company or business. It often comes down to culture. I think what the saying is, culture eats strategy for lunch.
I may use that. Thank you.
Which I think again was applied by a business expert, but it applies to so many other areas. So, well, thank you very much today, Andy, for the discussion and for sharing your expertise. I learned a lot myself, which I always enjoy doing. So we really appreciate all that. And thanks to Ecolab again for your support. To continue your learning on other pet food industry topics, including food safety, please watch for more Ask the Pet Food Pros. We have at least one more coming this year and probably more in the next year. We also have a number of webinars on our petfoodindustry.com website. So if you go to petfoodindustry.com's webinars, you can find upcoming webinars, plus all kinds of ones archived that you can watch the video of. And we have a conference coming up in Bangkok in October, which I realize is not feasible for maybe a lot of people on the call, but we also will have our annual Pet Food Forum conference in Kansas City in end of April next year. So watch for more information on that. If we haven't gotten to your question, again, remember that Ecolab will get a copy of the chat transcript and can follow up with you on that. And then finally, we would appreciate your feedback on today's chat. So you can either scan the QR code that's on the screen, or we also will be sending an email with a survey link, and we really would appreciate your input. Finally, just a reminder that this has been recorded, and the recording will be available within a week on petfoodforumevents.com under the Ask the Pro tab. So thank you again for joining us, everyone, and I hope you enjoy the rest of your day or evening.
Thank you all.